The purpose of this video is to test the camera block. Right now we're going to test the input for the environment. Over here we have a temperature sensor that reads 26 degrees Celsius, and our range is 60 to 80 degrees Fahrenheit, which is room temperature. 26 degrees Celsius is about 76 to 78 degrees, which would be in our range. Over here we have a lux meter, and our range is 100 lumens per meter squared to 400 lumens per meter squared, and we're reading at about 381 lumens or lux, which is exactly in our range. Over by the test object, we need to hit the range of 300 to 500, and it is sitting in that range around 470, and so that hits our environmental inputs exactly where we want them. The purpose of this video is to test the current output of a USB for the camera block to verify that we are receiving the correct current. Now, these resistors that we have available have a very low power rating of about 1/4 watt, so it's going to burn up pretty quick. So what we're going to do is we're just going to tap it to the end of this to test to make sure we're hitting the right milliamps here. It's going to be really fast, so hopefully we'll be able to catch it. And you'll see there we're right in between the range.
That was 150 milliamps?
Yeah. We're right in between the range, which needs to be 100 milliamps to 500 milliamps, so it is supplying the correct amount of current. Now we're going to test the voltage, which should be between 5.25 voltage DC and 4.75 voltage DC, because that is the standard output of a USB. So we just connect it to the other end here, and you'll see we're right in between that range, and the voltage nominal is also 5 volts, and so that will supply our cameras with the correct readout for input. The purpose of this video is to show that the input from the test object block is sufficient enough for the cameras to detect it. As you can see right here, the block is RGB color, which it has different colors on every side. It has green here, it has yellow, it has blue on the top, it has red, and on the bottom it has purple. The IR LEDs are currently on, but you cannot see them with visible light, and they're in a pattern in which it's recognizable. And so now all we need to do is show that the IR camera, which is hooked up to our computer over here, is within a foot of the test object, and it's detecting the IR LEDs, and so that also checks off as our IR camera is detecting IR light without being able to see it in visible light. We also can take a look here. If we go to our video capture pin, we can take a look and show what frame rate it's running at and the resolution. It's running at 30 frames and 640 by 480 pixels, which all we need is 24 frames per second, so that's actually running higher than our minimum standard, and our resolution is higher than our minimum standard as well, so that is well within range. Next we will test the RGB camera to see if it can do in focus. The purpose of this video is to show that the RGB camera is working as intended to output to the SBC. If you look, we have our RGB camera set up to look at the object, If I move my finger in front of the RGB camera really close, you can see my finger's kind of blurry. Also, if we zoom in or zoom out, in between, it's out of focus. You can see that it's blurry, but if we are in either of the settings, it focuses in on the object as it's supposed to. Now, it needs to have a resolution of at least 320 by 240, and our resolution on this camera is actually 640 by 480, as you can see here, and it needs to run at least 24 frames per second, and it's running at 30 currently, so that meets that requirement.